A linear resistor follows this relationship in the graph here. V is always equals to I, and R, most importantly, is constant. It's constant. No matter in what range of I, if it is negative, positive, whatever it is, and no matter what range of V, negative and positive, it always has this relationship. N plus R is constant. It does not change at different range of the current or different range of voltage. Let's see next example. See this example, the resistor here is nonlinear. This is the current, this is the voltage. It's no longer a straight line. In this case, the resistor is nonlinear. In all this course, we're assuming that all the resistors are linear. So we do not deal with this relationship. This relationship can be a p-n node or some other nonlinear devices. The concept of conductance, which is G, basically that's a reciprocal of R, this resistor. So G equals 1 over R, and that equals I over V. The units here, that has become interesting here. Either this is like a reciprocal of ohm. We know ohm is like this, right? So this is exactly upside down of ohm, which means the reciprocal of the resistor. Or yes, Siemens. So these are the same. So ohms is this OH. Yeah, exactly when we wrote it as becomes MHO for Siemens. For the power, this power equals V of I, that equals I squared R or V squared divided by R. Any resistors always consume power because the power always positive. We know that when the power is positive for any devices, that device absorb energy, consume power, consume energy. R, that's the resistor, always positive. That's R always greater than 0. Something squared, that's always positive. The same thing here. So this power always greater than 0. So therefore, resistor consume power. Also notice that power is a quadratic function of the current or voltage. So it's not linear, it's a quadratic function. It's not linear function in terms of current or the voltage. So that's the power. A simple example here, yeah, electric iron draws 2A at 200 volts, find the resistors. So we will see R equals 2A divided by I, that equals to 120 volt divided by 2A, that equals to 60 ohm, right? That's this question. The second question here, circuit is below, calculate the voltage and the conductance and the power. This is an easy one.